Good afternoon, dear children.
Good afternoon, ma'am.
How are you?
Fine, ma'am.
Hope everyone had delicious lunch today.
Yes, ma'am.
Are you feeling sleepy?
No, ma'am.
So, let us start our class today.
Yes, ma'am.
Today we'll be learning about an interesting concept. Are you ready for that?
Yes, ma'am.
But before that, we should have a quick recapitulation on the concept taught in the previous class. So, we will be using here KWL chart. This chart will help you to organize your thoughts in a proper way. Let us quickly fill that chart. So K stands for what I know. That means what you have learned in your previous class. So what you have learned in your previous class?
Ma'am, we have learned about various 2D shapes.
Okay, two-dimensional shapes. Next, anything else you have learned?
And we also learned about the areas of the shapes.
Areas. Okay. What are the two-dimensional shapes you have learned yesterday? Yes?
Trapezium and parallelogram.
Trapezium and parallelogram. Right. Trapezium and parallelogram. Next column. What I want to know.
Ma'am, we want to know more about 3D shapes.
More about 3D shapes. Okay. Anything else?
About the areas of the 3D shapes.
How to find the surface areas of the 3D shapes, right? So this column will be filling at the end of the lesson. What I have learned, right? So let me minimize. So kindly read this.
The ancient cultures throughout the world sought the idea of measurements for satisfying the daily needs. For example, they had to know how much area of crops needed to be grown in a given region, how much could a container hold, etc. These questions were very important for making decisions in agriculture and trade.
Right. Sit down. Thank you so much. Next, continue.
They needed efficient and compact way of doing this. It is for this reason mathematicians thought of applying geometry to real-life situations to attain useful results. This was the reason for the origin of mensuration.
Yes. So the ancient culture throughout the world sought the idea of measurements for satisfying their daily needs. For example, they had to know how much area of crop needed to be grown in a given region, how much would a container hold, etc. These questions were very important for making decisions in agriculture and trade. So they need some efficient and compact way of doing this. This is a region mathematicians thought of applying geometry to real life situations to attain their useful results. This was the reason for the origin of mensuration. So you are already familiar with the areas of plane figures like square, rectangle, triangle, circle, etc. These figures are called two-dimensional shapes as they can be drawn in a plane surface. But most of the objects which we come across in our daily life cannot be represented on the plane. It is very difficult to represent on a on a plane surface. Those three dimensionals are difficult to represent on a plane surface. So, we will be using a special technique like we will be using a net diagrams, okay, or isometric diagrams to represent those three-dimensional shapes. Clear? Can you give me some examples from your surroundings which are 3D shapes?
Ma'am, books.
Yes. Best example is your textbook.
Ma'am, the speaker.
Speaker, right?
And the wardrobe.
Wardrobe, right?
And the water bottle.
Water bottle, every day you are carrying Cylindrical. In shape it is cylinder. Right. Now these are some examples of cubes. These are some examples of cuboids and these are some examples of cylinder. Now here you see I have taken, this is what?
A piece of paper.
A paper. Can you see the thickness here? It is having a negligible thickness, right? So when I take some papers and pile up one above the other, you see, what do you observe here?
The height and the thickness increases.
Here there is having some thickness and this thickness gives you the new dimension, that is height. Now can you tell me this is of which shape?
Cuboid.
This is cuboid, right. Now I am having a situation before you. One of your friends is celebrating her birthday. So she invited you for her birthday party. And you all decided to go for the birthday party. So the first thing, what you will be doing?
They will buy her a gift.
You will purchase a gift. Very good. After purchasing the gift, you will carry the gift like that?
No, ma'am.
Then?
They will wrap the gift.
Directly you will grab the gift.
We will make it wrap
You will?
and we will put it in a box.
Yes, first you will put the gift in a gift box. And then you will decorate the gift box. So to decorate the gift box, what is required?
And wrap it.
A paper, a gift paper is required. So how will you know how much sheet of paper is required there?
We have to find the surface area.
Yes, you have to find the outer area of that circle, yes, that box, right? So here the concept of surface area comes. So today we are going to learn about surface area of solids. So let us see what is the surface area means. Yes, we read that.
The surface area of a solid object is a measure of the total area that the surface of the object occupies. We use square units to find the area of the region.
Very good. Sit down. Thank you so much. The surface area of a solid object is nothing but it is a measure of the total area that the surface of the object occupies. Okay, we use square units to find the area of the region. Tell me, where we are using it in our real life?
Then we can use the surface area to find how much paint is required to paint the house.
Yes, this is very important. You use the surface area to find how much paint is needed to paint a house. Yes, sit down. Next.
You could use surface area to find out how much cardboard make up a box.
Yes, you can use the surface area to find out how much cardboard make up a box. Also, you find the surface area of a cylinder to find out how much paint is needed to paint a fuel tank or to figure out how big a label for a container must be. So, your learning outcomes here, these are your learning outcomes. So, you will be able to understand the formation of cubes, cuboids and cylinders with the help of nets. You will be able to distinguish between the surface area of a cube, cuboid and a right circular cylinder. Read the third point.
Calculate the surface area of solids.
Yes, thank you.
Conceptualize surface area as a measure of wrapping.
Yes, conceptualize surface area as a measure of wrapping an object. Next.
Find the formula for surface area of cuboids, cube and cylinder by dividing into simpler pieces.
Yes, you'll be able to find the formula for surface area of cuboids and cylinder by dividing it into simpler pieces like rectangle, square and circle. Yes.
Solving problems related to surface area of different solids.
Okay, you will be able to solve problems related to surface area of different solids. Let us watch this video for better understanding. Let me then start our classes. Yes. Can you watch this video?
When we talk of surface area, we can be more specific by using the terms total surface area or lateral surface area. Total surface area is the area of all the faces that make up a three-dimensional shape.
So when we are speaking about surface area, means it is a total surface area of the shape, three-dimensional shape. So this is what? This is cuboid. Okay, it is having how many faces?
6 faces.
1, 2, 3, 4, 5, 6. It is having 6 faces. Each face is in which shape?
No, ma'am. Some are in square and some are in rectangle shape.
Okay. So I am saying this is your rectangular in shape and this is rectangular in shape. Right? So now when you see top and bottom, any relation you have?
Yes, ma'am, they are congruent.
Yes, the top face and bottom face have same shape and same size. They are congruent. Okay, now let us see how to find the total surface area of this cuboid.
Unless otherwise mentioned, surface area means total surface area. Lateral surface area is the area of all the lateral faces.
So what is your lateral surface area then? Yes, you take the example of your classroom. Right, your classroom is in which shape?
Cuboid.
Cuboid. It is having how many faces?
6 faces.
It is having 6 faces. So when I say lateral surface area means excluding the top and bottom, only the lateral faces. So we can say it has area of 4 walls. The lateral surface area is also known as area of 4 walls. Right? Now we will see how to find the total surface area and lateral surface area of a cuboid.
Of a three-dimensional figure. This three-dimensional figure is called a cuboid. How many faces do you think it has? Let's check. You can see that the cuboid
Here you see, this is what?
Net.
This is a net, which is a two-dimensional representation of your 3D shape. So when I close it, when I am closing it, I am getting a three-dimensional shape. Yes, you see here. When I am closing, I am getting a three-dimensional shape. Okay, this is my cuboid. When I am opening, I am getting a two-dimensional representation of the 3D shapes. So to find the total surface area of cuboid, you have to find the sum of areas of all these faces. Okay, since it is having 6 faces, you have to find the area of this face, area of this face, area of this face, area of this face, this, and you have to add total to get the total surface area of the cuboid. Right. Now let us see what is the area of each face. This is what?
Length.
Length. Okay, this is what?
Breadth.
And this is what?
Height.
Okay, so this area of this bottom, what is the area of the bottom?
Length into breadth.
Length into breadth. So area of top?
Length
Length
into
into
breadth.
breadth. Similarly, I am coming to the side face. So what is this? Breadth. This is what?
Height.
So area of the side face is what?
Breadth into height.
Similarly, this side face is?
Breadth into height.
And this is what?
Length.
This is what?
Height.
Area of this front face is?
Length into height.
Back?
Length into height.
So how many LBs we are having?
12.
How many BH we are having?
2 BH.
How many LH we are having?
2 LH.
So what is the total surface area of this cuboid?
2 LH plus BH plus LP.
Very good. Let us
has 6
watch this.
faces. Perhaps you'll understand this better if you look at the net diagram of the cuboid. Can you identify the shape of each face of the three-dimensional figure? Yes, each face is a rectangle. So, if you were to find out the total surface area of the cuboid, you need to add the areas of all the rectangles.
You have to
Let's
add
now
all the
calculate the areas of each of these rectangles. Do you notice that the areas of rectangles 1 and 3 are the same? The area of each of these rectangles is h into L. Similarly, the areas of rectangles 2 and 4 are the same. The area of each of these rectangles is b into h. The areas of rectangles 5 and 6 are also the same. The area of each of these rectangles is L into B. On simplifying the expression, we get the following formula for the total surface area of a cuboid. To find the lateral surface area,
Now let us find what is the lateral surface area of a cuboid. Lateral surface area of a cuboid means what? It is the lateral area of some of the areas of all the lateral faces. Right? So excluding top and bottom. That is what we are excluding? 2LB we are excluding. Let us see here.
we need to add all the areas of the rectangles that form the lateral faces of the cuboid. In other words, we add the areas of rectangles 1, 2, 3 and 4. On substituting the values and simplifying further, we get the formula for the lateral surface area of a cuboid.
Okay.
In a cuboid, the length,
So that is the lateral surface area of the cuboid. Now, suppose if all the faces are having same length, that means it is each face is square, then what shape you will get? Cube. That means I get this shape. Right? If you observe here, length, breadth and height all are same. So each face is square in shape. So what is the area of each face here?
Side into side.
Side into side. So how many faces we are having?
6 faces.
So what is the total surface area of a cube?
6 into side square.
Yes. Let us see here.
breadth and height are unequal. Now if we make the length, breadth and height equal, we get a three-dimensional figure called cube. On opening up the cube, we get a two-dimensional figure that
Yes. Now this one you see. This you see here. This is a neck of a cube. When I am closing, you see here. I am closing, I am getting a cube. Clear? And when I am opening this, I am getting a two-dimensional representation of that cube. So, the surface area of a cube is nothing but sum of the areas of all these faces. Clear? So, since it is having 6 faces, so each shape is square. So, area is a square. So, 6a square. Right?
6 faces. Each face is a square as its length and breadth are the same. So the area of one face is a square. To find the total surface area of the cube, we must simply multiply the area of one face by 6 as all the 6 faces are identical.
So now tell me, what is the lateral surface area of a cube?
4 side square.
As I told you, you have to exclude the what you have to
Top and
exclude?
bottom.
Exclude the top and bottom. So it is having only 4 faces. So area of a lateral surface area of a cube is nothing but 4
Side square.
That is 4 into a square. Each side we are each the length, breadth and height. We are taking it as a. Right? So it is 4a square. Right, good.
Actual surface area of the cube can be calculated by adding the areas that form the lateral surfaces of the cube. The area of one face is a square, and we have 4 such faces that form the lateral surfaces of a cube. So, the lateral surface area of a cube is 4a squared.
A cylinder is made up of.
Now, what is this shape?
Cylinder.
This is cylinder. It is having one curved face and 2 flat faces. Now, let us find out what is the total surface area of the cylinder as well as the curved surface area of a cylinder. Let us have a look.
Rectangle and 2 circles.
So, this is the net of a cylinder. So, when I am closing, I am getting a cylinder, right? When I am opening, I am getting here one rectangle and 2 circles. Okay, so the sum of the areas of this rectangle and this circle will give you the total surface area of a cylinder. Okay,
Yes.
so let us see what is the area of this rectangle now. What is the area of this rectangle?
L into B. Length into breadth.
Okay, okay. Let us see now.
Calculate the total surface area of a cylinder. We must calculate the area of the 2 circles and the area of the rectangle and add them together. As both the circles have the same radii, their areas should be equal. The area of the circular bases can be calculated using the formula.
What is the area of a circular base? It is pi r square. Area of a circle is pi r square. So here we are having 2 circles. So 2 pi r square. Now let us find out what is the area of this rectangle.
Pi r squared. And the area of the rectangle can be calculated by using the formula length into breadth. The length of the rectangle is the same as the
Here you see. Okay, when I am rolling this paper like this, here, and I am opening this, you observe this length. What is happening to this length?
The length is becoming the circumference.
Yes, the length here becomes the circumference. Right. So the circumference of the circle is nothing but 2 pi r. And here height is h. So the area of this one, you know, it is L into B. Here L is what? 2 pi r. And height is what? H. So area of this one is nothing but 2 pi r. That means the curved surface area of a cylinder is 2 pi r h. Clear. So for better understanding, let me use this GeoGebra app. The GeoGebra resources I am using here. Just observe this one. Here you just see, when I am sliding this one, you see what is happening here. See. You see that circumference is nothing but the length. Understand? So here L is nothing but 2 pi r. Right? Continue. Let us see it.
The circular base and the breadth is the same as the height of the cylinder. So, area of the rectangle is 2 pi r into h. To calculate the total surface area, we must then add 2 pi r h and 2 pi r squared. This can be further simplified as shown. The curved surface area, as the name suggests,
Yes. So what is the total surface area of this cylinder?
2
2
pi
pi RH plus 2 pi R square. That is, when you simplify, what will you get?
2 pi r whole r plus h.
Very good. Then what about the curved surface area of a cylinder then?
2 pi r h.
Simply it is 2 pi R H. Very good.
is the area of the curved surface of the cylinder. This means we do not include the area of the two circular bases. The curved surface area is therefore the area of the rectangular surface only. You have already seen that the area of the rectangular surface is 2 pi RH. So the curved surface area of the cylinder is also the same.
Hope everyone understand about the surface area of cube, cuboid and cylinder.
Yes,
But
ma'am.
now I have to test your understanding. So here some questions you have to solve, and let me see who will be quickly telling me the answer. Wait, let us have our first question. My first question is, calculate the outer surface area of an open cubical box of edge 20 centimeters that Kiran needs to paint. Who will answer? Yes?
And the answer will be 2000 centimeters square.
How did you solve that?
Ma'am, 5 into 20 into 20.
Why 5 into 20 into 20?
Ma'am, because we know that total surface area of a cube is 6 into side square. Ma'am, but the outer area is open, so there will be 5 surfaces. So the
Very good. Since the outer surface is calculate the outer surface area of an open cubical box. So one face is open there. So it is having only 5 faces. So 5a square. So 5 into 20 into 20 is nothing but 2000 centimeters square. Correct. Good. Sorry. Chalo. Next.
Ma'am, the answer will be 166 meters square.
How?
Ma'am, by the total surface area of a cuboid.
Total surface area of a cuboid is what?
2 whole LH plus BH plus LB.
Okay, fine, good. 2 into LB plus BH plus LH. When you simplify, you will get 166 meters square. Right. Now, last question. Yes, you answer?
And the answer is 90 centimeters.
90 centimeters square. How so quickly you have solved this question?
Ma'am, it is very easy. Ma'am,
How?
Ma'am, calculating the method that is 2 pi RH.
2 pi RH. The curved surface area of a cylinder formula is 2 pi RH. So 2 into 22 by 7 into R is 2 into height is 8. What is the answer? He told correct or wrong? Wrong. Only if you are saying that he told the wrong answer. Then what is the correct answer?
Ma'am, the correct answer is 100.57 centimeters square.
100.57 centimeters square. Let us see who is correct here. Yes, very good. So, you should not be hurry in solving the questions. You should read the question carefully and then you have to solve it. So, it is 2 pi RH. Fine. Anyhow, well tried. Chalo. So, we shall move the next. Here is a quiz for you. Answer this question. Read the question carefully and then answer. You have to explain me how you solve the question. Who will answer? Right. Tell.
it will be option D, 90 centimeters square.
90 centimeters square. You just tell me how he told the answer. What formula he has used here?
Ma'am, he has used the formula of TSA in cuboid. The length becomes 6 centimeter. The
Why
height
the length becomes 6 centimeter here?
as the cube are kept aside.
So if like these cubes, if you join two side by side, length of This is 6. Okay, when you join another cube, that also 6. So 6 plus 6 is 6 of 3. It is given, sorry, 3. So 3 plus 3 is
6.
But what about height and breadth?
Number remains the same.
They remain the same. Fine. So answer is 90 centimeters. Thank you so much. So let me open So in maths, anytime you make mistake while calculating, yes, we make mistakes. But making mistake is not a problem. But repeatedly you should not make that mistakes. You should rectify those mistakes. So this is error analysis. So in some questions, you are having the solutions. They are wrongly written. That the solutions are incorrect. You have to tell me what mistake you had in that and what is the correct answer. Yes, Tim?
Now in the first one there is mistake in the formula. It should be 2 pi rs plus 2 pi r square.
Yes, very good, very good. So find the total surface area of a cylinder. The formula should be 2 pi rh plus 2 pi r square. So the mistake is a formula. Now come to the second one, second question. Yes, tell me what mistake you have in this. Yes, let me show you. Yes, you tell me.
When the unit is wrong, ma'am, it should be meter square instead of
Ah.
centimeter square.
It is given meters and here the unit is centimeter square. It should be meter square. Very good. Sit down. Tell me, any mistake is there in this third question? Do you find any mistake? Who will answer? Yes, you can answer.
Ma'am, the process is correct, ma'am, but the addition is wrong, ma'am. The answer would be 2 into 54.
Where it is mistake you just, okay, 24 plus 12 plus 18.
Yes.
It gives you what?
54.
It should be 2 into 54. That means there is a mistake in calculation. Clear? So, when you try to find out the errors, you will be understanding in a better way. So, maths is such an interesting subject. Everywhere maths is present. Now here you see, I made a robot. Okay, with the shapes which was used in today's class. Here you see, we learned about cube, we learned about cuboid, we learned about cylinder. With the help of those shapes, I had created a. Like this, can you create any different shapes?
Yes, ma'am.
So this is your homework for tomorrow, right? Along with this, to know how much you understand, how much you understood, I had one worksheet. I'll be giving you that worksheet as a homework. Let me show you the worksheet. This, where is it? This one we had done now. Let me open the starter class. So your homework for tomorrow's class is you have to learn all the concepts what I explained today, including that you have to solve these questions. Let me show you these questions. So here are some questions. Note it down, these 3 questions as your homework. An aquarium is in the form of a cuboid whose external measures are 80 centimeter by 30 centimeter by 40 centimeter. The base, side face and back face have to be covered with the colored paper. Find the area of the paper needed. Can you do this question?
Yes,
Yes. Next join end to end to form a cuboid. Already this question we have done. Okay, that's also you have to do it. And this is the last question. In a building, there are 24 cylindrical pillars. The radius of each pillar is 28 centimeter and the height is 4 meter. Find the total cost of painting the curved surface area of all the pillars at the rate of rupees 8 per meter square. So these 3 questions, including one activity, you have to complete it and get it tomorrow. Thank you so much.